Working with the trig ratios to solve for either sides or angles takes some practice. Try and work through these next examples on your own, and if you need help, use this video to guide you through the solutions. In example 1, we have a ladder leaning against a building at an angle of 65 degrees. The ladder has to reach a window that's 17 feet above the ground, so we need to know what length of ladder will we need. Again, in these practical problems, it's best to start with a sketch. We have our building and the ground meeting at a 90-degree angle, and our ladder in between them. We know that the ladder needs to reach a window 17 feet above the ground. So this dimension here is 17 feet, and the ladder is leaning against the building at an angle of 65 degrees. We need to know what length of ladder do we need. So what is this length here? Once we have all that established, we can label our triangle. We can call this angle A, and label our triangle. This is our opposite side. Across from the 90 degree is always our hypotenuse, and then our other side will be our adjacent side. Looking at what we know an angle, so we need to know one more side, and we know the opposite side. We're trying to find the hypotenuse. So the trig ratio that has both opposite and hypotenuse in it is the sine ratio. Sine of angle A is equal to the opposite side over the hypotenuse. Subbing in what I know, the sine of 65 degrees is equal to the opposite side, which has a measurement of 17 feet, over our unknown hypotenuse, which I'll label x. The next step is to get x by itself. You may be quite comfortable with this rearrangement by now. I'll continue to do it in steps. To move the x out of the denominator or get rid of the fraction, it becomes a multiplication on the other side. X times the sine of 65 degrees is equal to 17 feet. To get x by itself now, I divide each side by 65 degrees, so x equals 17 divided by the sine of 65 degrees. From here, go to your calculator, make sure you're still in degree mode, and you can punch in 17 divided by the sine of 65. And we get 18.75. So we need about a 19-foot ladder at the minimum. Let's look at the next example. Here we have a road that has a slope of 3.5 degrees. We want to find the rise in 1,800 feet of horizontal run. So again, we have a road going up at an angle. If we consider the run and the rise, we know they meet at 90 degrees. The slope of this road, or the grade up, is 3.5 degrees. And we're given 1,800 feet of horizontal run and want to find the rise. Labeling what we know our angle A is 3.5 degrees. Looking across from that is our opposite side. Across from the 90 degree is our hypotenuse. And beside angle A is our adjacent side. We know the adjacent side, we want to find the opposite side, so we'll be using the tan function. Tan of angle A is equal to the opposite side over the adjacent side. So the tan of 3.5 degrees is equal to x, our unknown opposite side, over 1,800, our adjacent side. To get x by itself, we multiply tan 3.5 times 1,800. If you like, you can write the x on the left, our unknown, 1,800 times tan of 3.5 degrees, and then we can punch that into our calculator. Check on your calculator. You may not need the multiplication sign. You may be able to just punch in 1,800 and then tan 3.5. Oops, I missed the decimal. So I can use my backspace. 3.5 equals 110.09, or to one decimal place, 110.1 foot rise in 1,800 foot run. We have one more example to practice with on the next page. Here we have another example with the slope of a ramp, and we're told that the building code states the ramp must have an incline angle of no more than 10 degrees. We know the ramp climbs 3 foot 6 inches and has a run of 9 foot 2 inches, and we want to know, is it up to code? In other words, is the angle of incline 10 degrees or less? If I sketch this out, it climbs 3 foot 6 inches, so that's my rise, has a run of 9 foot 2 inches. I want to know angle A, the angle of incline. Labeling my triangle, I know the opposite side and the adjacent side, so I'll be using the tan function to solve for my unknown angle. However, notice that I have different units. I have mixed feet and inches. To put them into the fraction or the ratio of sides, I need to have all the same units. In order to avoid you dealing with decimals or fractions, I'm going to convert to inches for both the rise and the run. So 3 foot 6 inches, 3 feet, times 12 inches per 1 foot will give you the number of inches in 3 feet, and then make sure you remember to add the other 6 inches. So the 3 feet is equal to 36 inches plus 6 inches. This is a total of 42 inches for the rise. If you do the same for the run, we get 110 inches. Now that we've sorted out our units, we can figure out our angle. The tan of angle A is equal to the opposite side over the adjacent side. So tan of angle A is equal to 42 inches over 110 inches. To get the angle by itself, we move the tan over using the inverse function of tan times 42 over 110, and then we can go to our calculator. The inverse function of tan I get to using my second function of tan, bracket 42 divided by 110, close the bracket, and I get an angle of almost 21 degrees. So this is definitely not up to code. This ramp is much too steep. Challenge yourself now and try and calculate. If we know we need a rise of 42 inches, what run would be needed to have only a 10-degree incline? So this is what we'll try and solve to answer that question. We know we want a 42-degree rise, and we can't have anything more than a 10-degree incline. So let's figure out our unknown run or our adjacent side. Again, we know the opposite side, we want to find the adjacent, so we'll use the tan function. Tan of an angle is the opposite side over the adjacent side. We know our angle this time. We're going to use that 10-degree limit. The opposite side is 42 degrees, and we want to find the unknown adjacent side. Try and do that rearrangement in one step. You've seen it a few times now. X equals 42 over tan of 10 degrees. And then we can go to our calculator. 42 divided by tan of 10 degrees is 238.19 inches. Try and use your skills from previous modules to convert that to mixed feet and inches. You should find that you get about a 19 foot, 10 inch run.